This is about a new approach for solving the toughest problems with numerous elegant solutions, with a new AI-assisted multidisciplinary solution engine. There are common approaches for common problems, which are appropriate. There are some assumptions around these methods. The problem is common and well understood. The causes are known with high confidence. The effectiveness of solutions is well known. The problem-solving process and the results satisfy everyone's requirements and expectations. But there are potential deficiencies. Quality of analysis is a function of the individual group members, their experience, and the group dynamics. Proposed solutions are not tied back to causes. Only a single root cause is assumed to exist. Limited understanding of the system or process. Limited number of opportunities for improvement are identified. Limited number of solution options are generated. With this new approach, there are different assumptions. The goal is to completely solve the problem without adding complexity, significant costs, or trade-offs. Based on research, science, and experts, so causes or solutions are not generated through brainstorming. To start with, this method starts with defining a problem that is intractable, which is a very important problem, and one that has been focused on several times, without success. So far, you may have only generated solutions that are complex, expensive, difficult to implement, and that represent trade-offs. It is clear that we need a rigorous, objective, science-based method for identifying causal factors without brainstorming. Otherwise, we utilize brainstorming to identify the relative factors. For example, better brakes, road conditions, driver is distracted, warning sensors not working, and so on. As an example, here is this different bottom-up approach. We say there are two basic factors to begin with. That is, we have large number of cars on the road times the percent of cars that rear-end the front car. For the next level, we borrow from common physics equations to identify the distance to the lead car is small, the trail car speed is fast, stopping ability is low. As part of being multidisciplinary, we also look at cognitive behavioral analysis. This goes beyond human factors engineering to the thought process that leads a person to make safe or unsafe decisions. Usually ignored. The best technical solution can be sabotaged by behavior. Identify causes or precursors to behavior, but you don't have to be a psychologist. Read some recommended papers, articles, studies, etc. and use AI to get educated why people make safe or unsafe decisions, as well as data to support your analysis. You can see in this diagram that the driver's behavior can be driven by cognitive bias, emotion, motivation, social norms, and subconscious calculation. Next, we look for contradictions, which we find during the science-based causal analysis and cognitive behavioral analysis. Contradictions are seen when one attribute or factor could have two opposing values. As we insist on maintaining the need for both values, it seems impossible to solve. Some examples include, I want to go fast, but I should go slow. The freeways should have a large number of cars on it, but should there be less cars? I want to follow closely behind the front car, but I don't want to. I get angry about slower cars, but I should not be angry. Instead of pursuing what we think is the root cause, you will likely identify at least 15 opportunities for eliminating the problem, as opposed to just continuous improvement. To resolve these contradictions, we utilize trees, or the theory of inventive problem solving. Utilizing the best and most relevant solution strategies that have been used in patents, we can choose from 50 different approaches, e.g., separate the two desired values gradually. We want to allow a high number of cars entering a freeway, but we want fewer cars on the freeway. We can use ramp metering, which allows the freeway to hold as many cars, yet with more space between cars, resulting in fewer accidents. This solution is well known, but this process reminds us of it. we can easily identify at least 20 more elegant solutions for the base problem. Again, our goal is always to pursue solution concepts that would meet our criteria for elegant. That is, they should be of relatively low cost, it should not add significant complexity, and opposing goals for the contradiction should not result in a... Last, but certainly not least, is the importance of artificial intelligence within this solution engine. AI is not going to do everything for you, at least not yet. Just as with so many other applications of AI, we need to already be aware of how to do the task, along with all the subtleties, and know what to expect as far as reasonable answers, or else you could be led astray, or you wouldn't know if you are missing something. Therefore, it is essential to thoroughly learn these methods. But when you have gathered an appropriate amount of knowledge and skill in all the tools and effective prompts, AI can then help tremendously to improve the breadth, depth, accuracy, and speed across all of the steps. Remember, this isn't for simple, clear problems where causes and solutions are already known. You probably already have a good process for solving them. You could say, this is serious medicine for serious problems. If you want to learn more, consider attending one of our awareness sessions, followed by introductory training, then in-depth hands-on training, and finally, one-on-one coaching.